Welcome. Welcome to Presto, you got it, where we use insightful comments and analysis to make your learning easy, interesting, and fun. Most importantly, our insights will help you truly and deeply understand what you want to learn. Very crucially, we emphasize important concepts multiple times in a seamless way so you can appreciate, consolidate, and internalize the essence of the material, relatively speaking, with little effort. In addition, on academyforadvancedstudy.com, we offer at a very affordable price tutoring programs that cover SAT, ACT, AP, all the college prep materials. Of course, we also cover many K-12 subjects. We even cover college level material. Furthermore, we, again at very affordable price, we offer tutoring program for advanced topics such as statistics, computer science, data science, business intelligence, and artificial intelligence. We also cover programming and engineering. If you want to go to medical school, we can help you too. Again, at a very affordable price, we offer tutoring program for medical school prep, such as MCAT. Now let's go back to our talk today. What we are going to talk today is step-by-step procedures to compute correlation coefficient. We have a fictitious data set here. We have 5 students, A, B, C, D, and E. Student A studied for 2 hours, got 65 on the test. Student B studied 4 hours and got 70 on the test. Student C studied 6 hours and got 75. Student D studied 8 hours, got 80 on the test. Student E studied 10 hours and got 85. You probably can detect some patterns here. For every 2 hours student studied, they got 5 points more. Of course, this is a fictitious data set, and we just want to make the computation a little bit easier. You can probably guess what the correlation coefficient will be. So let's find out step by step. What we will do first is to calculate means of x and y, x being the hours studied, y being test on the score on the test. For x, we have 2 hours, 4 hours, 6 hours, 8 hours, and 10 hours. We calculate the total, which is 30, and we divide it by the number of students, 5, and we have 6. You can probably use what you learned in algebra and by observing the symmetry we have here, and got that 6 very fast. Then we calculate y bar. That is the average or mean of the test score. What we have here is 65, 70, 75, 80, and 85. Again, we construct this data set to make the computation easier, and also very importantly, to make the computation conceptually understandable. It's very important because usually you cannot do everything by hand. We have even with small data set, you're going to have sufficient computation to make your understanding a little bit difficult. So what we want to do here is to use a perfect data set, quote unquote perfect, to help you conceptualize the essence of the material here. So that's step one. With step one, we have x bar, which is the mean of x. We have y bar, which is the mean of y. X being the hour studied, and y being the test score. Step two. So what we're going to do in step two is to prepare all the data, the intermediate result we need for calculating the correlation coefficient. To appreciate that, let's go first take a look at the formula for correlation coefficient. Well, this is what we call Pearson correlation coefficient. This is a standard formula. Later on, we're going to cover a formula expressed in the terms of z-scores. So we will study this standard formula first. It looks like quite complicated, but it is not that bad. So we will conquer this formula step by step. We will first look at the numerator. Numerator will have a summation. Summation is the term of summation is not that difficult to comprehend. So we have xi minus x bar multiplied by yi minus y bar. So x bar, y bar is what we just calculate in step one. And in step two, we plug in xi being the hours studied for the ith student, and yi is the test score for the ith student. So what we have here is the two terms multiplied together, and in the table above, we actually have this intermediate result for x minus x bar and y minus y bar. So here, if we observe this table, what we have is for column 4, we calculated all the x minus x bar values for every student. So for student A, we know the average number of hours student studied is 6. So on column 2, student A studied 2 hours, and 2 minus the average hour, which is 6, is 2 minus 6 is minus 4. For student B, that is 4 hours minus 6 hours, that minus 2, which is recorded on column 4, x minus x bar. For student C, the x value is 6 hours, and identical to the average hour studied, so it's 0 on column 4. Student D, he studied 8 hours, and minus the average 6 hours, we got positive 2. And student E, he studied 10 hours, and 10 minus 6, that's 4. So that's how we arrived at all the values we have here on column 4. We can do the similar thing for Y, and on column 3 we have the test score for all the students. For student A, his score is 65. We know the average Y bar is 75, which is what we calculated in step 1. So 65 minus 75, we got minus 10. This is what we have on column 5, Y minus Y bar. For student B, he got 70 on the test, so 70 minus 75, we got minus 5. For student C, she got perfect average score 75, so the difference is 0. For student D, he got 80. 80 minus 75, we got 5. For student E, he got 85, and 85 minus average 75, that's 10. So on column 5, we got all the values for Y minus Y bar. And so this is with these two columns, we can actually do the summation to calculate the value for numerator. So now let's take a look at the. Actually, we have an intermediate result that already covered both the x minus x bar and the y minus y bar. And so on column 6, we have 40 for student A, and the 40 is just the value on column 3 and column 4 multiplied together. For student A, that's minus 4, and multiplied by minus 10, so we got a positive number 40. For student B, we got minus 2 multiplied by minus 5, so we got positive 10. For student C, we got 0 and 0, so the multiply 0 and 0, of course we got 0. And for student D, we got 2 hours times 2 times 5, so we got again positive 10. For student E, we got what we have is 4 multiplied by 10, and again we got 40. So on the last row, we actually have a sum of all the numbers we just talked about on column 6. So we have 40 plus 10 and plus 0 plus 10 again plus 40, so total we have 100. That's a last row and 6th column, we have 100. So this is the value of the numerator in the correlation coefficient formula. So next, the last two columns, we compute what we need for computing the denominator in the correlation coefficient formula. So let's take a quick look of the formula itself. So as we can see, to compute the denominator, we need to calculate 2 square root. Each square root is constructed by summation and the sum. Okay, so the first term, the sum is the all the value of xi minus x bar squared, and again xi here is the hour studied for I student, and so for the second term, what we have in the sum is the yi minus y bar, the squared, and yi being the test score of the I student. So now we know to calculate the denominator, we need the xi minus x bar squared and yi minus y bar squared. So let's go back up to find out what we did in columns, last two columns. So we have this x minus x bar squared, and for student A we have 16. How we got 16 is simply the we square the value on the column 3, and for student A that's minus 4, and we square that. We square minus 4 and we got 16. And for student B, we square minus 2 and we got 4. For student C, we square 0, so we got 0. For student D, we square 2, we got 4. For student E, we square 4, we got 16. So now let's calculate y minus y bar squared. Again, all we need to do is to square the value on the column 5. For student A, we have we square minus 10, and we got 100. For student B, we square minus 5, we got 25. For student C, we square 0, we got 0. For student D, we square 5, we got 25. For student E, we square 10, we got 100. And on the last row, we sum all the value above. So we add 100, 25, 0, 25, and 100 together. Total we will have 250. So all we need to do now is to plug in all the numbers on the last row into the correlation coefficient formula. And this is what we have here. So numerator will be 100, denominator is 40 square root, and 250 square root multiplied together, and we got 10,000 inside the square root, and for the new denominator, and both the numerator and the denominator we have 100, and so we got a perfect 1.0. That's our correlation coefficient. Wow, what a nice number. Yeah. Again, as we mentioned before, we want to make this computation conceptually easy to understand, so you can really internalize the essence of the material here. So we covered the standard formula for correlation coefficient. Now let's try the different formula. That is a formula expressed in terms of z-score. This is actually quite interesting idea. So step 4, z-score method, and the first step within this z-score method is to calculate standard deviation. It's tough, so actually it's not easy to calculate by hand. Here we got square root again, and we already calculate the xi minus x bar squared, and we just we sum everything together. We know we have 40, so we have the new denominator here is n minus 1, n being the number of students. So we have 40 divided by 4 and the square root. So we have square root of 10, and using with the magic of a calculator, we know it's 3.1623. We do the same thing for y. Again, we can use the table we already covered to find out the sum of yi minus y bar squared, that is 250, and divided by n minus 4, n minus 1, so we got 4, so 250 divided by 4, we have 62.5, square root, we have 7.9. It's not easy here because we don't have whole numbers. But still, that's something we need to appreciate what computer can do for us. Either computer in your calculator or in your personal computer. Life is much easier with them. So in step 4.2, we compute z-scores. Here we have the formula for z-scores. We have zxi, that is the z-score for the hour studied for student I, the I student. So the formula already know what it is. It's xi minus x bar divided by standard deviation for x. And we do the same thing for y to calculate the score of every student to find out the z-score of their test score. So here, numerator, we have yi minus y bar, and divided by standard deviation. So we actually have a table here, and with all the intermediate result we have, and so we have student A, we have zx, that's x z-score for student A, and for student B, for student A, we have a minus 1.26. It's kind of a nasty here, a lot of digits, and it's not that easy to comprehend. But that's what we need to do. So all you need to do is to use the formula above to calculate the z-score for each student. And we have two z-scores we need to calculate. The first z-score is for the hour studied, that's zx. The next z-score is the for y, that is test score. So for student A, the z-score is minus 1.26, and for both, of course, you probably already know what it means. The z-score for each student, the z-score for hours studied and tests, they are identical. We have a perfect linear relationship here. That is what it means. And we multiply the two scores together for each student. And what we have here is for student A, we have multiplication of two z-scores, it's 1.6. Now you're wondering, wow, how do you get this perfect 1.6 here? Of course, it's a magical computation. Well, assuming we didn't lose any accuracy. So for student B, we have 0.4. This is just a multiplication of column 4 and the column 5. And so again, we do the same thing for student C. It's 0. And for student D, it's 0.4. For student E, it's again 1.6, perfect 1.6. We add everything together, the last column, and we have a perfect 4. What wonderful life! Now we are ready to use the z-score formula for correlation coefficient. Again, we have n minus 1 on the as a denominator, and the numerator, it's a sum, and it's a sum of last column we just finished, and we just plug in the value, and that's 4.0. That's the last row of that table above. And so we have 4 over 4, and that's perfect 1.0. So again, we arrived at the same number, same value, 1.0. That's our correlation coefficient. So to conclude what we just talked about, we have presented 2 ways to calculate the correlation coefficient. Of course, you will never do this by hand. It's with any reasonable size of a data set, you have to use a computer. But here we just want to really truly internalize what correlation coefficient is all about. And so for standard formula, we have R, correlation coefficient, perfect 1.0. For z-score formula, we have the same, exactly the same value, 1.0. So we know we have a perfect positive linear relationship between the hour studied and the test score. Alright, so that's all we have today, and hope you enjoyed. Remember, on academyforadvancedstudy.com and academyforadvancedstudy@gmail.com, we offer tutoring program at very, very affordable price. So come to see us. That's all for today. Thank you. Have a great day.